tried our best to get a room, but it's a dental building, so I refused that and I instead chose this location. Before we start the class, probably I should make it clear I'm video recording this class and asking for your consent, of course, because the reason is I know some people might not be available to come due to other academic requirement. Some people might not just show up. That's a different story, but I'd like to upload this video to YouTube or some other mechanism so that students can at least see what we discussed in the class, so that they are also informed of this. So I think that's the most easiest way of, instead of trying to reschedule another class with a lot of things going on in your life at the end of the semester. So do you have any problem? Are you guys okay? No problem? Video recording? No problem. Okay, so feel free to ask your question. This is probably and I will remove that after 1 week or so from that side. I did this earlier in other classes for these kind of reasons. Okay, so maybe we can close the door. Okay, so the purpose of today's class is mainly to talk about the ITS, Intelligent Transportation System, which is becoming a more emerging field in our field because we started to understand the technology can probably change a lot in terms of how we monitor our systems, in terms of data collection, in terms of even facilitating vehicles or roadways in different ways. So we will be trying to mainly talking about in this class the major ITS which are being used already in practice. I will give some idea what research are trying to achieve, but today most of the things that we will be talking about is already in place. People from in different cities are using that on a day-to-day basis. So what is ITS? It's basically use of this emerging information technology in transportation system in order to improve efficiency, safety, reliability. So those are the main. How can we utilize that? There is major two areas where we are utilizing ITS in a greater scale. One is highway management. Advanced traffic management and information, often called ATMIS. So any kind of use of those kind of technology is already in place in Toronto. I mentioned about it in other classes, like this video recording of 401 or major 400 cities highways. They capture those videos and do the image processing and try to come up with what's the delay time, and then give a automatic feedback to 401 those variable signage, like saying that collector is moving slow, go to the express is moving slow, go to that. So this is in Toronto. In the United States, it's going really fast in terms of these kind of variable signage. So what it does is, of course, reduce the congestion. It's try to maximize the utilization of road space for a given set of resources. So it's a demand management in a sense approach as well, instead of having another new highway built. So IT in many ways are helping us to do demand management in some cases. So ATMIS is a huge area. Last 30-40 years, people are working on it. They are coming with new ideas. For instance, I talked about it in my tech conference. People are now looking at vehicle platooning, they are thinking about talking sensors with the control station, and maybe one day we will have some sort of highway. It's possible, it's feasible because of the advancement in sensor technology particularly. As you might know, this Daltrack is also have planned to put those kind of wireless sensor system in Halifax roadways, particularly in the bottlenecks, to have a 24-hour, 24/7 kind of a vehicle monitoring and give feedbacks. It might also help, I saw there are other, like in addition to this congestion effect and other kinds of things, it also help to radio broadcast, public outreach. As you guys know, like you hear 95.7, like this road is going slow, that road is going, that kind of things. It's still based on those crowdsourcing or some sort of reporting that in Halifax, that kind of technology. But in Toronto, actually every day, like the radio station actually come to that lab, University of Toronto lab, and they sit there, they see all the videos, and they can actually report online, live, like what's going on in which kind of highways. So there are other ways of also like giving access to these kind of information to the public. So those kind of benefits too. So that's an ongoing kind of utilization of these kind of ATMIS. And we are hoping probably one day we might get that kind of information as well. It helps in various ways, particularly for the incidents. Like if something is happening somewhere, some collisions, like it's very easy to let everybody know all at once, like what's going on, which road to avoid. And since we are having these kind of issues quite often, like it's very important. So this is one area. Another one is emerging, but people are trying to really capitalize the benefits of ITS is Advanced Public Transit System, APTS. That is another big field, like what we can do for transit to make it more competitive to auto. For example, those priority signal system. I will be talking about that more in a minute. So what we can do to give priority signals, giving green extension for transit vehicles, and red truncation otherwise. So that's one way of doing that. Second is, like for example, I talked about those automatic fare collection, which reduce the dwell time. So all things are about travel time. How we can improve travel time, efficiency, and reliability. I will be talking about that as well. Reliability is also a big issue. How we can make our transit reliable, on schedule, those kind of things. Yeah, go ahead.
And efficiency, like there's probably technologies that see how many people are waiting at the station, or like they're developing, I imagine.
Exactly.
Like, do we need to send the bus? Or
right, those kind of things as well, and also efficiency in terms of like public information. How many, what time you are expecting the bus, or those kind of things. We'll be talking about even over phone. That's fine, even if you doesn't have enough resources to have those kind of panels everywhere, unless it's a Union Station or like high. But you can do a lot of things. App. That's another research area. It's not yet the practice. Why not we have something in our app, like the weather, that we can quickly check. We might have an app. We can know, number one, Dalhousie bus is delayed, or like those kind of things. So it's an enormous field. It's a very growing, exciting field, I would say, and it will probably change a lot in those kind of things. There are other two which I might not like touch much on, is that commercial vehicle operation, CVO, that's another one, and automated highway system. These are all emerging. CVO is important freight, like for Halifax particularly. For example, weighing motion, like we do not need to like stop a truck to take its weight. There are sensors now available. We can remotely actually tell what will be the weight of that particular kind of traffic, and it's important for the aging infrastructure. Like like our two bridges are quite aged, and structural health issues of those bridges. So we need to really understand like what we should be allowing, what we should not be. So CVO is doing those kind of things. So why ITS is of course this congestion, pollution, and another one is emerging, is still not being used, is the pollution sensors. Like putting pollution sensors in roadways so that we know what is the total pollutions are coming and what will be the exposure to the people, those kind of things. So it's coming, it's not, still not in the practice, but I'm assuming within 30 to 40 years, probably less than that, you might see more and more of those kind of things, because we have done these kind of things already very successfully in environmental science, in weather forecasting. Like we have these kind of network nodes and those kind of things already. So it probably, so there is a huge area of like ITS or use of technology in transportation system to improve efficiency, reliability, and safety. So this is one of the slides we always use. It's a test bed, GPS, you have a one control system. So this is emerging. This is the conceptual kind of model of what the University of Toronto's transportation lab has. We are replacing that with Dowtrack. We have just recently done that. I should replace this slide as well. So the idea is like we should collect those kind of things and have a GIS model, data server, and try to monitor, real-time monitoring of whatever we can do, either traffic or pollution, or I think Metro Transit is already developing some sort of this kind of control center with AVL system, automatic vehicle location system. I'll be talking about that as well. The go times. How many of you know about go times? So go times is a kind of ITS application. So this is the conceptually people are moving forward. So let's start talking about this APTS, which has some implication with your project as well. That's why I was so concerned, like these snow days is taking my class out. In your project, you might need to add some of these elements as a package for BRT. So that is another reason, like I was trying to get this class a makeup class. So APTS, the transit ITS, some people also talk. So it's a public transit has a lot of issues, coverage issues, frequency issues, reliability issues. So we can do a lot of things with the speed and reliability with APTS. So that's the idea. That's the idea we need to do. So these are the things probably you all know. Like timetable says bus every minute. 8:30 you are waiting in the bus stop, then 8:35, then 8:40, then you see that no bus is coming, right? But all once, like you just get like multiple bus coming all together. So bunching is an issue, like unless you have this kind of control, this is probably your everyday experience anyway, but this is one way of illustrating the same thing. So another unreliable passenger information could be like you're calling, you know that bus is scheduled at 5:35, but you are saying that it's left early from the location that you studying. So these are some sort of like common kind of experience that we are having, so we can improve those things by using ITS. That's the main idea. So the impact, as you all probably know, is passenger dissatisfaction, reduced demand. This is a cycle in many ways. Uneven passenger loading, that's another issue. That's why maybe you are seeing a lot of buses are empty in various times, because it's not scheduled. Like there could be planning issue, but there could be also this kind of information issue. People do not trust about the reliability of the service. That has a huge problem for the efficiency and productivity of transit services. And now let's look at what are the causes of poor speed and reliability. What are the causes? Tell me.
Congestion.
Congestion is one cause, okay. What else?
The schedule.
Schedule is another cause.
Lots of stops.
Lot of stops. So space planning issues like stop spacing. What else? Of course, you guys are right so far. Congestion, incidents, mid-block, those kind of things. There is a huge component in delays.
Demands. Pedestrian demands, like so, or I mean ridership demands. So it's like everyone wants to go catch a bus because they need to be at school for 9, and everyone wants to be on that one
Right,
bus.
so that's the planning issues, scheduling issues, resource issues, those kind of things. There is a huge component in transit which cause delays.
Signal.
Signal. Signal is a huge component in which is the delays is 25% at traffic signals. So we have to work on the travel time, right? How to improvise that travel time. So delays at traffic signals is actually 25%. Congestion and other things can be taken into account if you are a good scheduler, right? You know every day there will be some congestion in some point. We are talking about reliability. Reliability means when you say that in one stop the bus will come at that time, you should have that on that time, unless there are incidents. So incidents is another one. We cannot improvise unless just the safety measures. But otherwise we can do through planning a lot of improvement, like your schedule, like you know always there will be a congestion in Bedford Highway, so you schedule each stop in that way. Here we are talking about reliability more, and of course the speed, like speed is more related with the congestion and other things, but reliability is important, like how we can like improvise on that. But here, traffic signal related is 25%. So what people found is like improving, like using the ITS, like that's where we can improvise. And there could be the same thing, like you guys come up, variable loading and unloading. Like if people are not, like if we don't know where we need how much time for dwell time, it's really hard to schedule and tell that. So we can find those kind of things. Route configuration, like stops, spacing, timetable design, like you have to do that. Like the transfers should be coordinated by from one bus to another. Driver's characteristics, vehicle breakdown, those are probably more outliers or peripheral. We might not have some issues, but training can improve those kind of things. But what I will try to focus in this class is how we can improve on these traffic signal delays, which is 25%. And weather related, of course. So possible remedies is of course exclusive dedicated bus lane, like which that can solve most of our problems. But of course we don't have enough space. We don't have enough like with the historical town like Halifax. Like it's hard like to get exclusive dedicated bus lanes, like unless we are really planning long range from now to get those kind of things. We can also do these electronic fare collection. That's an ITS application. Like that will reduce your delay time. We are doing these kind of things. I made this argument before. Like we are doing, the coffee shopping is so easy with PayPass. Why we need to have those exact change to ride a bus? I just don't get it. We can use so many things, even smartphone or phone-based kind of fare or any kind of card. Like it's not a expensive technology, but it can really reduce huge amount of your dwell time. Like if you can board in both doors. You know, so there are huge improvements that we can do for this fare collection if we are doing quite well. And these transit priority signals to reduce delay of transit vehicles at signalized intersection. So that is important. So signalizing intersection are in a way is very beneficial if you have those, and you can give preferential treatment. So we'll be talking about that, and that is one of the reasons sometimes I'm not very much enthusiastic about these roundabouts, like which Nova Scotian are right now trying to put in many places, because you are losing the probability of putting this kind of transit priority signals, since this will no more a signalized intersection. So if you want to give this priority signal for transit in the future, maybe we'll evolve, maybe we'll see more opportunities to offer better kind of transit services, but we are like now start treating those all in the same way, car and transit buses. I understand the roundabouts can reduce the traffic speed, that's good, but you have to also think about like that possibility as well.
You always just put in a dedicated transit lane around the roundabout.
it's not feasible for Halifax, no way, that
In the long term.
even in the long run, because you don't have road space. You don't have road space, like within your, around your commons, for instance. Where is that lane coming from, right? You don't have that. So I don't see, what I see is with roundabout, yes, it can, certain places, it may work well, right? But we have to always have a first plan of our high priority, high frequency transit corridor identified and stay away from those for putting this kind of permanent structure. But those kind of things can be useful in many places, like where it also reduces the operation cost. That is one of the reasons probably most of the traffic engineers are quite excited about it, because you don't need those kind of traffic signal and other kinds of, and that's good. Roundabouts are working well in Europe, like in England, like they have a very good use of that. Roundabouts are also working well with signalized intersection in Washington DC, for instance, but we don't have that kind of space to have a roundabout with signalized intersection. But I'm not saying that roundabouts are not good. It's just it should not be blanket approach of like putting everywhere. It should be particularly for wherever we are thinking we will be putting some sort of express transit routes. It's better if we have those signalized intersection, because then we can work on transit priority treatments, queue jumping, those kind of things. Otherwise, we are mixing everything up. Transit schedule, headway regularity, those kind of things can be done through operations, but riders information system is also another way of like maximizing the efficiency of these kind of things, and also satisfaction of the passengers. Like, people want the right information. People do not, like, an unknown 5 minute is more painful than known 7 minutes. Like, that's how I interpret it. Like, if I know I have to wait 7 minutes in this stop, I know, yes, the bus is coming within 7 minutes. But maybe the bus is coming within 5 minutes, but I do not know about it. Human psychology, like our studies suggest that people do not like that kind of things. So reliability, all goes to the reliability. So riders information system can improvise on that. If you know, yes, there will be delay of this ferry coming, people are okay. And the people may be scheduling that way. Like you will start for your departure time from this lab to your bus stop. When you know that it's 5 minutes late, you have 5 minutes to work on other things. Right? So those kind of things. Another huge thing going on is the Wi-Fi and other kinds of things putting in the buses. Like that, those are also improvising satisfaction of the passengers. Now, so for all of those kind of things, like public information, these real-time information system, or even offering some sort of transit priority system, this is one system people are utilizing a lot, which I was referring to, AVL system, automatic vehicle location system. Go times is based on that. So it's nothing but like having a GPS in every buses, and you know where they are, where is the delays, and you can also communicate with the drivers to do this way, that way, whether they're behind the schedule or ahead of schedule. So you can do a lot of different kinds of things. So and this is a very positive approach most transportation agencies are taking. In any way, we all are emitting our location every time, isn't it? Right? With your cell phone, you're always emitting your location. Whether you are enabling or disabling that piece, it doesn't matter. You are giving exact, precise location, even if your GPS is closed, because you are communicating through towers. So we can, by triangulation, mathematically we can prove where you are at a certain point of time, if someone wants to do that. And you guys have probably are also following this Malaysian Airlines, right? The one which disappeared recently. They have only 1 or 3 or 4 ping point. Ping means just one signal, they might be in that location. The mathematics, the beauty of mathematics was like from those 3 or 4 points, they could like come up with 2 routes. One is northward, another was southward, and it proved like we are quite sure like it's in the southern Indian Ocean. So this is same technology we are talking about, the same kind of understanding, same kind of satellite system, same kind of GPS. So these things can improvise in various ways. So AVL system is one good one. A system used for monitoring the location of transit vehicles in real time, and there are many ways of doing AVL system. It's not always required these kind of very expensive like systems like GPS or like the whole other kinds of things. You can do in various ways. Like even like the early AVL application was say based on the distances, like your signpost, some sort of odometer or some sort of signpost sensors, like just to get where your vehicles are, just a mechanical detection, those kind of things. Or the GPS system is more advanced and mostly used AVL system. We can also use, so I'll come back and just introducing those technologies that we use in public transit, automatic passenger counter. That's also a good understanding of your uneven or even kind of a passenger expectation, your dwell time, so it will help you for scheduling. So we need those kind of things for various reasons, and it could be infrared beams, it could be treadle mats, for example, signpost, odometer. A bus is there, in the signpost you have some sort of detection technology, and you know like whether that's in there. So that's a very easy technology, old technology, and then you send that signal to control center. So that's a good one. And the GPS system is like the same way. You have the GPS and those kind of things. I was quite lucky in Lisbon World Conference on Transportation Research Forum 2010. They gave a technical tour to their transit management center, and I was so amazed. Like in Lisbon, like they have like a huge kind of a infrastructure to locate their vehicles, and there are 4 or 5 transport planners like have this zonal kind of responsibility. They are looking at it, where they are, and they are continuously communicating with those drivers, continuously communicating or updating their website so that everybody knows where the buses are. I was quite impressed. And Portugal is not like the biggest or richest or kind of technologically advanced compared to other European countries, but they are really making use of whatever they can do to improve public transit and transportation system utilizing this technology, just more out-of-box thinking so that they can actually invest on that. And once you start pulling out your resources to these kind of like the modes, like transit and others, you will see that land use and other kinds of things automatically actually they will be saying that, you know what, we are not getting another highway. So we have to build there because transit people are using that. So transit might become one of the main features when you are selecting your location, right? Some people does, like I was, like when I was a student. I was only looking at how close I can live within GO station. That was the major. How close within walking distance, rain or shine, because that can minimize my time requirement. That was my main criteria, and the second criteria was like how close I can live within a daycare center, because I have a child at that point. So those 2 were the main criteria. Price was the third. Price was not the first, because those can reduce my price as well, like in various ways, but that was the main. So what I'm saying is, like, if the city or like anyone like start really redirecting their vision, redirecting their commitment to these kind of like public transit or other kinds of systems that can improve our pollution, congestion, and all kinds of issues, you'll see that there will be a lot of trickle-down effect or peripheral effect here and there of this kind. And APC is nothing but just aligning and voting how much we can do that. So I will not talk about the APC a lot, but I think I should talk about this transit signal priority system, which you might also be including in your study of bus rapid transit. So I think it's a good idea. So there are 2 methods. 2 methods of offering generally, and of course putting two methods is one is passive signal priority, second is active signal priority. Passive means a low-cost, fixed timing plans based on transit services. You don't need transit technology to detect. It's like you know the bus will be scheduled there, assuming that bus schedules are reliable and high-frequency route. You can always change your signal timing to give extension to those buses. Like you can plan, like on the drawing board, based on your planning, you can do those kind of passive. It's appropriate for high frequency and reliable routes. So you can if you know like the bus will be in that second in that section of the roadway, you can easily for that period of time, particularly for the peak hour, you can give signal priority. So it's more planning your signals in a way that favors public transit, not the car. Right now, as you guys know, most of our green wave, you know green wave? No? Feel free to please raise your hand whenever you feel like you are not getting that point. Like in general, the way traffic engineers put those signal timing is for green wave. If you start driving, recall your driving experience or being a passenger. If you are driving, if you get a one green signal, usually you start getting green signal in every intersection because it was designed in that way. So green wave. If you're getting one red signal, you will see that you are getting the next red signal again, red next signal again. Because we try to take like the flow to go like as smoothly as possible, giving those kind of green wave. So that the signal timing is like designed in a way so that like the time it requires from one intersection to another intersection, we design that signals in that way. Like it's just the timing, technicians does that. Like if you just plan as a planner, like what should be those kind of timing. So that's how we design. That's why you'll see like the flows are going very well, and when you are driving. So this is the other way around. Like instead of like doing it for the cars, because we calculate for cars, those kind of things, can we calculate the same thing for transit? Because we know when the transit will be there in different stops. Instead of intersection base, we can do stop base. So there are a lot of people working on, even in research field, how we can improvise that. So without technology also, my point is, we can actually offer transit priority signals. It's not BRT, even for the regular buses, we can do that. There is also another good thing going on, those who are interested about active transportation. Can we give green wave for bicycle, if we have bicycle lane?
They do that in Copenhagen.
Yes, they do. They does that. So you guys have seen that in the video. So that's the same. So it's like the which mode you are giving kind of references. So this is the same kind of approach, and it's good. It's good. So the thought process is shifting right now, and there are tons of evidences of throughout the world having these kind of transit priority signals, passive transit priority signals. The one which is getting much more attention or investment in these days is the active transit signal priority system. Because in passive signal priority system, you need a reliable route, you need a high frequency route, and which is almost non-existent. Right? So usually that only work, otherwise it might cause delays, it might, once the your synchronization like gets disrupted, so it will be really miserable in various ways because we are talking about one or two buses, those kind of things. But for high frequency routes, I can see that is one good area. But to do those kind of things, we need to also know dwell time, we also need to know various kind of things.
It would probably work better for buses or light rail that has like exclusive right of way because
you don't need any even signal priority for exclusive right of way.
Oh, sorry. Yeah.
High frequency. It's only for the high frequency. It's only high frequency and reliable routes, like the Bay Street in Toronto, like very high frequency. It's right inside that. For the exclusive right of way, it's always best.
The active signal priority, is it like an electronic device installed in each bus?
Right.
This is similar to the one on the ambulance?
No, I'm giving that. So active tracing, I will be talking more about active signal priority system. So it's like let's make this case quickly. Like the vehicle should be able to communicate with the traffic signal controllers. And there is a traffic signal controller in every intersection. Have you guys ever noticed that? There is a big box, rectangle in every intersection. Look at it, that's the traffic signal controller. It's in place. So what we need is a GPS or some kind of a location technology so that it can emit, like I'm here, and change like your signal, or do a signal that can favor me. So that's the basic idea. That is the basic idea. But so signal timing modified in response to presence of transit vehicle upstream of signal. So whenever we can do that, and I will be showing more details about how we do that. So that's how we do. Usually 3 methods within active signal priority. One is unconditional, like there is no condition, and there is another is conditional and adaptive. I will explain that. Unconditional is most commonly used right now. Conditional and adaptive is more in the research field. People are trying to develop a little bit better system day by day. We are not there yet. I will explain both. First, let's start with the unconditional one, what we can do and what we do. So the objective is to reduce signal-related delay of transit vehicles while minimizing impacts on general traffic. So we have to also think about the general traffic as well. So minimizing impact on the general traffic, but trying to reduce in signal-related delay, particularly in the peak hour. Like that's where we are talking about. Generally, off-peak hour, everybody